As a first concrete example, let's make an application that has a simple slider and a plot that updates the plot somehow based on the slider. For the first part of our application, we will need several familiar imports: figure, layouts, column data source, and the curdoc function mentioned earlier. We also import slider from bokeh.models, and we import numpy in order to use it to generate some random numbers for us. Next, we create a column data source by hand and initialize columns x and y with some random points. It's very common in Bokeh applications to create column data sources explicitly whenever we want to be able to update that data interactively. Next, we create a plot, just as we have seen before, by passing the names of the columns as x and y arguments and passing in our column data source as well. Lastly, we see the call to slider. This creates a slider widget that can be part of our application. We configure it with start and endpoints, an initial value, a step size increment for the slider, and a title. Having created a slider widget, let's make it useful by adding a callback to it. First, we define our callback function. Bokeh callbacks can be added to any property, and the function always has the same format: 3 parameters: attr, old, and new. They provide the attribute that changed, as well as the old and new values. The Bokeh server will supply these values whenever it calls one of your callbacks. In this callback, we read off the value from the slider with the n equals slider.value. Then we create a new data dictionary for our column data source with the new numpy arrays of random points. The number of points is determined by the slider value. Setting the .data attribute on the column data source is the only action required to update the plot. No special trigger or commands are needed. Bokeh will notice the change and synchronize the new values in the browser, causing the plot to update to reflect the new data automatically. Callbacks like this are attached to Bokeh objects, such as sliders, using the .onChange method. We call onChange with the name of the property we'd like to watch as the first argument and the callback as the second. In this case, we want our callback to execute whenever the value of the slider changes, so we call slider.onChange with the arguments value and callback. For our application, we want the slider above the plot, so we call column with the slider and then plot as arguments to get the vertical layout we desire. Then we call curdoc.addRoot of layout. This adds the layout and all that it contains to our current document. Nothing else is needed except to run the application and use it. Here we can see the final application in action. Another common control that is useful in Bokeh applications is a drop-down menu. Using this control, we can allow users to do things like select between different data sources to view, or pick different algorithms to try out. Let's adapt the previous example by using a drop-down menu instead of a slider. The first part of our next example is nearly identical. Instead of slider, we import select from bokeh.models. We create exactly the same data, column data source, and plots as before. At the end, we call select to create our menu. Select accepts an options parameter, whose value is a list of strings to display as the items in the menu, as well as a value parameter, which names the currently selected item from the menu. In this case, the options are uniform, normal, and log normal. The initial value is uniform. We also provide a title, as before. What about our callback? Like all callbacks on Bokeh properties, it accepts the attr, old, and new parameters. Inside the callback function, we inspect the current menu value. Depending on the value, we create new data from either a uniform, normal, or log normal distribution. We create a new column data source data dictionary with these arrays and assign it to source.data. We add our callback using menu.onChange just as before. The remainder of the example follows the first slider example. We put our widget and plot in a column and then add the layout to our current document using curdoc.addRoot. This is how the finished app looks running. The last example we take a look at will show how to add and use buttons. There are many additional widgets available that we don't have time to cover in this course. consult the user's guide at bokeh.pydata.org for additional examples and information. In this video, we will cover a few different kinds of buttons. You might want to have buttons that let users start a computation of some kind or download results of data as a CSV. The main difference between simple buttons and other widgets is that their callbacks are simpler. When a button is clicked, that is an event that happens. There is no value that changes that can be watched. This is reflected in the code seen here. We import button from bokeh.models and then create a button with a label. Next, we create a callback for the button, but notice that the button callbacks do not take any arguments at all. Just like other callbacks, we can do whatever we like inside the function, look up data from a database or a file, call out to NumPy or Pandas, or anything else Python can do. Then, instead of onChange, we add the button callback using button.onClick. Since there's no specific property that we are watching, we pass the callback as the only argument. It's worth mentioning that there are a few different types of buttons in addition to plain buttons. Here we see some example code that creates a toggle, checkbox, and radio group buttons. These buttons all have the notion of an active state. Is the button currently on or off? And for checkbox and radio groups, which buttons are on or off? Bokeh expects callbacks for these types of buttons to take a single parameter, active, and when the server executes the callback, it will use this parameter to provide information about which button is currently active. Here we see several of the button styles all together. Now that we know how to create Bokeh applications that can connect interactive web visualizations to all the powerful PyData tools such as NumPy, SciPy, Pandas, and others, let's talk about how to share those applications. In Chapter 3, we've seen how simple it is to create richly interactive data and visualization applications locally using Bokeh. Other people can also run your applications locally too if you share the application code with them. It's also possible to publish or deploy Bokeh applications for larger audiences, for instance across a company network or publicly available on the internet. Depending on your requirements, this could involve some additional configuration of web technology such as load balancers. Much more information about deploying Bokeh applications can be found in the Running a Bokeh Server section of the user's guide at bokeh.pydata.org. However, starting in early 2017, Bokeh applications can be published easily on anaconda.org. All the configuration and web tech required for deploying a shareable Bokeh application will be handled automatically, so you can focus on your data and visualization. For more information, navigate to this URL.